RMS velocity, average velocity, that is the C bar, and most probable velocity CP. Okay, last class I was discussed about the RMS velocity, that is the C, and average velocity C bar, and most probable velocity CP. Okay, and it is the RMS velocity is the 3RT by m. 3RT by m, that is the 1.58 into 10 to the power of 4 and the square root of T by m centimeters per second. Centimeter per second. This is the RMS velocity. And average velocity C bar is equal to 8 RT by pi m. 8 RT by pi m. And the value is C bar is equal to 0.9213 into RMS velocity. RMS velocity. That is the average velocity. And next one, most probable velocity. Most probable velocity Cp is equal to and the square root of 2RT by m. Okay. So Cp is equal to 0.8166 into RMS velocity. This is the last class, the 2RT by m, and this is the 3RT by m. Okay, so RMS velocity C is equal to square root of 2RT by m, and average velocity C bar is 8RT by m, and most probable speed Cp is equal to square root of 3RT by m. Here the C value is 1.58 into 10 to the power of 4 and the square root of temperature by mass volume, that is at centimeters per second, and C bar average velocity 0.9213 into RMS velocity, and most probable speed Cp is equal to 0.8166 into RMS velocity. And relation of these three, C RMS means C is to C bar is to Cp. So దాన్ని ఎలా రాసుకున్నాం, మన రివర్స్ లో రాసుకున్నాం. ఎట్లా? The relation of the Cp is to C bar is to C, and means most probable average velocity and RMS velocity. We know that the final value 1 is to 1.12 is to 1.22. This is the relation between the molecular velocities. Relation between the molecular velocity, that is the 1 is to 1.12 is to 1.22, or root 2 is to root 2, 8 by pi is to root 2, 3. This is the molecular velocities of the relation or ratio. Clear? Okay, Nana? So molecular velocity, RMS velocity, average velocity, most probable velocities. Now I will discuss about the Maxwell-Boltzmann distribution of molecular velocities. Maxwell-Boltzmann distribution of molecular velocity. So this concept molecular velocity distribution is explained by the Maxwell-Boltzmann based on the graph. He is explained, both are explained the molecular velocities of distribution of molecular velocities based on the graph. Okay, so first of all, molecular velocities, we know the molecular velocity, there is the most probable speed and average velocity and RMS velocity. Okay, now according to kinetic molecular theory, we know the kinetic molecular theory of gases కొన్ని postulates చెప్పుకొని ఉన్నాం. So what are the postulates of the KMT? What are the postulates of KMT? KMT postulates. Based on this KMT postulates, we explain the Maxwell-Boltzmann distribution of molecular velocities. So molecular distribution of molecular velocities explained by the Maxwell-Boltzmann based on the kinetic molecular theory of gases postulates. ఈ postulates of KMT ని బేస్ చేసుకొని ఈ Maxwell-Boltzmann distribution of molecular velocity ని explain చేశారు. Okay, so what is the first one? What is the first postulates of the KMT? So all gaseous molecules moves random in all directions with different velocities. So that is we know that point in the KMT postulate. మనందరికీ తెలుసు KMT postulates. All gaseous molecules moves in all directions with different velocities. So all gases moves randomly in all directions. At the same time, ఎప్పుడైతే మూవ్ అవుతున్నాయో that molecules are collide with each other. Collide with each other. As a result, ఏమవుతాయి ఇప్పుడు they give different velocities. The different velocities are one is the most probable speed and second one average velocity c bar and c RMS velocity. So what is that point? According to KMT postulates, all gaseous molecules are moves randomly in all directions. That moving of the gaseous molecules collided with each other. As a result, they give the different molecular velocities. The different molecular velocities are most probable speed and second one average velocity and third one RMS velocity. The Maxwell Boltzmann give a representation of these three velocities. So how the representation? The Maxwell-Boltzmann gave a distribution of the molecular velocities in representation of the graph. So the Maxwell-Boltzmann give a distribution of the molecular velocities. Distribution of molecular velocity based on the graph. Okay, the plot the graph between number of molecules versus molecular velocities at different temperatures like T1, T2 and T3. Here T3 is higher than T2 and T1. Okay, so catch the point. So Maxwell-Boltzmann give a distribution of the molecular velocities. Okay, that molecular velocities depends on the molecular velocity depends on temperature and molecular mass of gas. Here the plot the graph between number of molecule versus molecular velocities at different temperatures. The different temperatures are T1, T2, T3. Here T3 is greater than, T2 is greater than T1. Here means that T3 is higher than the T1 and T2. Okay, Nana? So draw the graph. Here the number of molecules and here velocity. Okay, number of molecules, velocity. Okay, Nana? Here the number of molecules versus velocity at different temperatures. This is the T1 and T2 and this is the T3. Okay, once again I will repeat it. All gaseous molecules moves randomly in all directions. The moving of the gas molecules collide with each other. As a result, they give the different velocities. So different velocity means all gaseous molecules moves randomly in all directions with a different velocities. That point explain. All gaseous molecules moves randomly in all directions with different velocities. That means that moving of the gaseous molecules collide with each other. As a result, they give the different velocities. The Maxwell-Boltzmann give a distribution of the molecular velocities. Here the molecular velocity depends on the temperature and molecular mass of the gas. And next one, the plot the graph between every graph draw chestunna number of molecule versus velocity velocity at different temperatures T1, T2 and T3. Here the T3 is higher than the T1 and T2. That means T3 is greater than, T2 is greater than and T1. Based on the graph, at any temperature, ఏమవుతుంది గ్రాఫ్ చూడండి అన్న, at any temperature the molecular velocity at any temperature the molecular velocity is a higher value and higher speed, at the same time lower speed at any temperature. At any temperature T1, T2, T3, here T3 is higher than the T1 and T2. We draw the graph between number of molecules versus velocity. At any temperature ఏమవుతుంది, at any temperature the plot gives different velocities. At any temperature gives different velocities, means at any temperature the plot gives higher molecular velocity and lower molecular velocity. Okay, the maximum in the curve represents the maximum curve represents ఏం రిప్రజెంట్ చేస్తుంది, maximum curve represent different velocities. The gaseous molecules possess ఏమవుతున్నాయి, the gaseous molecules possess maximum velocity is there. The maximum curve represent gaseous molecules possessed by the most probable speed. Means or the speed possessed by the maximum number of velocities. The speed possessed by the maximum number of velocities is called most probable speed, CP. As the temperature increases, so we draw the next graph. It is the number of molecules. Here the velocity. Once again I will draw the graph. Okay, once again I will draw the graph. It is the M1, M2, M3. M1, M2, M3. It is a CP. It is a C bar, and it is a C. It is the most probable speed. It is the RMS average velocity. It is the RMS velocity. Okay. So the graph draw between number of molecules versus velocity. The maximum curve represents the gaseous molecules possessed by the maximum number of molecules. So that maximum number of molecules speed possessed by the maximum number of molecules is called most probable speed, CP. This is the most probable speed. Most probable speed means the maximum curve represents the speed possessed by the maximum number of molecules is called most probable speed. Here the temperature increases. CP also increases. As the temperature increases, ఏమవుతుంది, CP also increases. As the temperature increases, the graph ఏమవుతుంది, the height of the graph decreases. The height of the graph decreases and finally flatter and finally ఏమవుతుంది, so it is almost touches the velocity line. Okay, clear. The temperature increases, ఏమవుతుందన్నా, the temperature increase చేస్తున్న కొద్ది ఏమవుతుంది, the temperature increases, the height of curve decreases the height of curve decreases, okay, and curve flatten and broader, okay. So clear? Once again I will repeat it. So at any temperature ఏమవుతుందన్నా, at any temperature the molecular velocities gives different velocities. As the temperature increases, it gives the high velocity value and low velocity value. The maximum curve represents the speed possessed by the maximum number of molecules is called most probable speed. The temperature increases, most probable speed also increases. Temperature increases, most probable speed also increases. The temperature increases, the height of the curve, temperature చూడనా, T1 is the lowest and he is the highest, and compare with the T1 and T2, T3 is the highest temperature. As the temperature increase చేస్తున్న కొద్ది ఏమవుతుంది, the graph is decreases, it is a flattened and finally broadened. Clear? Okay nana. So once again I will repeat it. ఇక్కడ కూడా చూడండి nana, number of molecule versus velocity at a different molecular masses m1, m2, m3. The maximum curve represents the speed possessed by the maximum number of molecules. It is called most probable speed. As the temperature increases, if the molecular mass increases, the height of the curve decreases, and finally flattened and finally broadened the velocity line. Clear? At any temperature, the order of velocity is Cp is greater than C bar is greater than C. At any temperature, order of velocity Cp is greater than C bar is greater than C, means most probable speed is greater than average velocity is greater than RMS velocity. RMS అని రాస్తున్నాను, కొంచెం క్లియర్ అవుతుంది. ఓకే, మోస్ట్ ప్రాబబుల్ స్పీడ్ is greater than average velocity is greater than RMS velocity. ఓకే, as the temperature increase చేస్తున్న కొద్దీ at any temperature the order of velocity ఏమవుతుంది, most probable speed ఎప్పుడు highest ఉంటుంది compare with the average velocity and compare with the RMS velocity. Okay, clear? Once again I will repeat it. In the distribution of molecular velocity based on the KMT postulates, what is the based on the KMT process? All gaseous molecules are moves in all directions with different velocities. The moving of the gaseous molecules collided with each other and have a result, it gives the different velocities. The different velocities are Cp, C bar and C. The Maxwell Boltzmann give a distribution of molecular velocities, and the distribution of molecular velocity, the molecular velocity depends on the temperature and molecular mass of the gas. The plot the graph between number of molecule versus molecular velocity at a different temperatures T1, T2 and T3. Here T3 is greater than, T2 is greater than T1, means T3 is higher than the and T1 and T2. This is the graph number of molecules versus velocity at different temperatures. At any temperature the molecular velocity higher value, and also molecular velocity is at high temperature and low temperatures. At any temperature the molecular velocity is higher value and lower value. The maximum curve represents the gaseous molecule, the speed possessed by the gaseous molecules, the speed possessed by the maximum number of molecules. Speed possessed by the maximum number of molecules is called most probable speed, that is the Cp. The temperature increases, most probable speed also increases. As the temperature increases, the height of the curve temperature increase చేసే కొద్దీ the temperature increase చేస్తున్నాం. Here T3 is a higher temperature compared with the T1 and T2. The temperature increases, The graph means height of the curve decreases. Height of the curve decreases. The curve flattened and becomes bordered. Becomes bordered. So temperature increases, the height of the curve decreases, and the curve flattened and becomes bordered. Okay. At any temperature, the order of velocity is Cp is greater than C bar is greater than C RMS velocity. Clear? Okay. The most important one point in the molecular velocity is Maxwell-Boltzmann curve. At given temperature, heavier molecules have lower speed than lighter molecules. According to Maxwell-Boltzmann distribution of molecular velocity, at a given temperature, heavier molecules have lower speed than the lighter molecules. అంటే ఎవరైతే heavier molecules ఉంటాయో వాటికి lower speed ఉంటుంది compare with the lighter molecules. For example, we take the N2 and Cl2. We take the N2 gas and Cl2 gas. Here the N2 atomic weight, what is the atomic number? 7, and atomic weight is the 14. And here the 2 nitrogens are there, and 14 plus 14 ఎంత అవుతుందన్న 28. It is the molecular mass of the nitrogen N2 28. Here Cl2, one chlorine is the 17 and atomic weight 35.5. 35.5 ఎంత అవుతుంది? 1 10. Okay, 10 11 and 6 71 అవుతుంది. Okay, here the chlorine molecular weight is the 71. Compare with these two, N2 and Cl2. ఈ రెండింటిని కంపేర్ చేయండి. What is the highest molecular mass? Chlorine, Cl2, and lowest molecular mass? N2. So N2 moves with high speed compare with chlorine. Why? At a given temperature, heavier molecules have a lower speed than the lighter gas molecules. Based on these 2 points, and here we take the N2 and Cl2. Which one is the low molecular mass? N2. So it is the N2 moves with high speed compared with the chlorine. Why? Ante at a given temperature, heavier molecules have lower speed than the lighter molecules. Clear? It is the Maxwell-Boltzmann distribution of molecular velocity. And finally, conclusion, simply one conclusion: the temperature increases. ఏమవుతుంది? The temperature increases. It gives the different velocities. That means lower velocity and higher velocity. The temperature increases. The velocity decreases. The graph, the maximum curve decreases. As the temperature increases, the curve decreases, and curve become flatter and finally broadened. So that is the only one point in the Maxwell-Boltzmann distribution of molecular velocity. As the temperature increases, the curve decreases, and curve pushes, flattened, and finally bordered. It's the maximum curve, and it's the flattened and finally bordered. At any temperature, the 3 relations of the most probable speed, RMS velocity and average velocity, the Cp is greater than C bar is greater than RMS. And finally, one conclusion, most important point in the Maxwell-Boltzmann distribution curves: at a given temperature, heavier molecules have lower speed than the lighter molecules. For example, we take the N2 and Cl2. Here the N2 is the low molecular mass compared with the Cl2. So N2 moves with high speed compared with the chlorine. Clear? This is the Maxwell-Boltzmann distribution curve. Okay, Nana? And next one. ఒక సమ్ చేద్దాం మనం దీని మీద, ఈ వెలాసిటీస్ మీద. చూడండి నాన్న, the average velocity of nitrogen, the average velocity of nitrogen at 27 degrees centigrade is 0.3 meters per second. Meter per second. At what temperature? At what temperature? At what temperature it will be? It will be 0.6 meters per second. Okay, so chudandi, the average velocity of nitrogen at chudandi, the average velocity of nitrogen at 27 degrees centigrade, the average velocity of nitrogen at 27 degrees centigrade is 0.3 meters per second. At what temperature it will be 0.6 meter per second. And the nitrogen at 27 degrees centigrade, the average velocity is 0.3 meters per second. But what temperature the average velocity is 0.6 meter per second, and 0.3 meter per second temperature is 27 degrees centigrade. But 0.6 meter per second velocity, what temperature of the nitrogen? So what is the average velocity? The average velocity is equal to C bar is equal to under square root of 8 RT by pi m. This is the average velocity. The ratio of velocity at a different temperatures of a gas is the ratio of velocity at different temperatures of a gas is C1 bar by C2 bar equal to under square root of T1 by T2. But actually that average velocity is the C bar is equal to 8 RT by pi m. But based on the ratio of velocity, the ratio of average velocity at different temperatures of gas is C1 bar by Ct is equal to under square root of T1 by T2. Here we know the T1 value and C1 bar value, C2 value. Here the T1 value is 27 degrees centigrade. It convert to Kelvin, it equal to 273. We get the 27 plus 273 equal to 300 Kelvin. Here the degrees convert into Kelvin. Add the 273, it equal to 300 Kelvin. We know the value C1 is what is C1 value? 0.3 meters per second, and C2 is 0.6 meters per second. We calculate the T2, that is a question mark. Substitute the values in the formula. The ratio of the average velocity of the different temperatures is C1 bar by C2 bar is equal to under square root of T1 by T2. The C1 is 0.3 and C2 bar is the 0.6 under square root of T1, and the T1 is the 300 Kelvin by, and T2 is the question mark. So T2, we find out the T2. So 0.3 by 0.6, that is equal to 1 by 2 under square root of 300 by T2. Squares on both sides. Squares on both sides. Squares on both sides. So we know the 1 by 2 means 1 by 4 equal to square and root cancel 300 by T2. 300 by T2. Okay. So you get the cross multiplication. The T2 is equal to 300 into 4. That the T2 is equal to 1200 Kelvin. The Kelvin convert into degree centigrade, add the T2 is equal to 1200 Kelvin, 1200 minus 273. We get the 927 degree centigrades. 927 degree centigrade. That is the temperature of the average velocity of the 0.6 meter per second velocity. So that the temperature we get the velocity 0.6 meters per second. So clear? So this is stop. Tomorrow I will continue molecular velocity and some problems. Thank you, Nana.